Now number 5 on the optimization activity is similar to the last one we did, where we were trying to maximize the area of a rectangular vegetable garden, but in this case it's similar but a little bit different, because what happens here is we have a rectangular plot of land that's bounded on one side by a river and on the other 3 sides by a single fence. So it's the same setup, right? But in this case we have a river here, right? So here's my river, and what we're going to be doing is we're going to be building a fence along the river. So we're going to be building a rectangular fence like this. And what they're telling you is that there's going to be no fence along the river. So we really only have 3 sides for the fence. So it's a similar setup where we have a rectangle, but now we only have this L over here, and we have these 2 widths over here because the river forms the other length. So what we know, the constraint is that there's 800 meters of wire. So that's the wire is going to be along here, right? So what we know is that if we take, and this is the constraint, the 2 widths and that length together, so in other words 2W plus L, we've got to end up with 800 meters of wire, right? Technically it's less than or equal to 800, but we're assuming we're going to use it all, so we're saying 2W plus L equals 800. That's our constraint. And now the function that we're trying to optimize, right, maximize in this case, is, again, the area. And the area doesn't change. Now the perimeter basically is only 2W plus L versus 2W plus 2L, but the area is still going to be L times W. Right? And now we're just going to do what we did before. So take our constraint, which was 2W plus L equals 800, and solve it for one variable. Now in this case, could I solve for W? Sure, but it's just easier to solve for L because that's already by itself, right? There's no coefficient. So we just get rid of this 2W. So we have L equals 800 minus 2W, right? So now our function to optimize is no longer LW, because we're going to replace the L with 800 minus 2W. So our function to optimize now becomes M equals 800 minus 2W times W, and again distribute, and we get 800W minus 2W squared. And luckily for us, this is again a parabola that has a maximum point, which we can find just using our negative b over 2a formula. So we do negative 800 over 2 times negative 2, which is negative 800 over negative 4, which is actually going to be 200. So our width is going to be 200 meters, and our length then is 800 minus 2 times 200, right? All I did was just plug in W for 200 for W in this equation up here. So I get 800 minus 400, which is 400. So that's my length. So my length is 400 meters, and my width is 200 meters. And in this case, the difference is they actually asked us for the largest area and what are its dimensions. So we have the dimensions here. The length is 400 meters, the width is 200 meters, but the area is then just going to be our length times our width, which is 400 times 200, which is actually going to be 80,000. Oh, it's meters, sorry. It's not square feet. It's 80,000 square meters. Right? So we make length 400 meters, width 200 meters.